Assalamualaikum, my name is Muhammad Syamil bin Abdul Hadi. So today I'm going to do part B, open the PID controller, tuning and simulating run the system and analyze the engine speed when different speed reference are used. Okay, so this is for the first one. Okay, the first one is step time is 2, and then we click okay, and let's see the engine speed RPM. Okay, this is the graph. Okay, it will be 2 here. And then if we change the value of speed reference, value step we change to 3. We click apply and then okay. And then this is the graph. The step time will be at 3. Okay, for the next one, analyze the engine speed when different PID parameter are used. Okay, this is I use PID. I set it proportional to 1 and integral to 1. Okay, and then let's see the graph will be look like just now. This is the graph, and then if I change it to PI, different PID parameters, I change to PI, the value of proportional 1 and integral is 1, and then apply okay, and then the graph will be look like this. This is the graph for the PI. Okay, that's all from me for the part B. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Makmal and I'm from group 4. Okay, for this lab, in the experimental setup, to begin with the clinical method, we use Simulink embedded software to get the transient response for open and closed loop. We use the clinic close tuning, the second method, when we use the gain instead of PID controller. So we begin with a low value of gain and increase it until we occur a steady state oscillation where we note this gain as K-Ziegler system. The parameter that we got from this method will give us response with an overshoot but with a good setting time. Secondly, for P controller using PID tuner, we replace the gain block we used previously in Ziegler-Nichols method with PID controller. Then, the parameter that involved in this study is PID structure for the Simulink Kp plus Kis plus Kds. For structure of the PID equation, according to a PID experiment, the PID must have 3 primary components. Kp proportional with use K as a gain device and connect to the sum component. Kp for the time of decrease, Ki integrated, Kd derivated. The Kp, Ks and Kd will join on the sum and go to the transfer function. The switch was made. Okay, then we move to the part 2, PID control experiment using try and error. We gonna build the required block diagram using Simulink. First, we're gonna open the MATLAB, then open the Simulink block diagram, and we're gonna create a block diagram. The component that we're gonna put in the block diagram is, for the first is step, and then sum, PID controller, transfer function, MUX, and last for the scope. Okay, then we connect it. Okay, here is the block diagram of P controller. Okay, then after that we got the diagram, we can move to the result and analysis in the part 2.
Hello and Assalamualaikum. My name is Muhammad Shamil. So I'm going to continue to part number 2, PID control experiment using trial and errors. So for this part we use our own block diagram. So we change U to P for the 2.2 P controller. We change U to P and we use the value proportional 1. We click apply, OK. And then for the step, we use step time is 2, initial value is 2000 and final value is 3000. Then we click OK, and then let's see the graph. The graph will look like this. This is the rise time and others. Then for the next one, we change the value of proportional to 0.1. We click apply and then OK. And then this is the graph. This is the difference between the first one is here. And then for the next one, we repeat the 2.1 experiment using PI controller. So we change here to PI controller. We change here and we use value 1 and 1 also. We click apply and then OK. Okay, for this one, let's see the graph. The graph will look like this. This is the rise time. And then for the next one, we change value here to 0.1 and 0.1. And then this is the graph. Then the difference is this one. And then for the next one, repeat the 2.1 experiment using PD controller. So we change here to PD controller. The value here is 1 and this is also 1. We use the same step as before. We don't change it. Okay, this is the graph will look like. The graph will look like this. And then for the next one, we change the value of the proportional and derivative to 0.1 and 0.1 also. Then click apply, then OK. Then we go to scope and this is the graph. And then for the last one, repeat the 2.1 experiment using PID. So we change here to PID. We set here to 1 and also 1. Okay, so this is the graph. And then if we change the value here 0.1 0.1. This is the graph, the last one. Okay, that's all from me for part 2. For the 2.6, I already put it in your report. So that's all for me. Thank you.
Okay, hi and Assalamualaikum. So I will explain the part 4 for PID controller auto tuning. So this is the block diagram for PID controller. So we set we add PID controller and the result that we get for block parameters is this is the block parameters PID controller. So we set to the PID, pi, PD and P. So at first we set for pi. So this is the graph that the graph. So for the table, which is the parameters, so this is the value of the controller parameters that we need to find. So we need to do it to do another, which is for the pi, PID and P. So we change to PID. So for the PID, we apply and tune. After we apply, we tune it and we can get the graph. So this is the graph for PID tuner, and this is the parameters. So we repeat the step. The step is the same, and we repeat it for the P and PID, PI. That's all. Thank you. So this is the performance that we get. So we can just look through into this. So that's all for me. Thank you.